Hello, so I thought I'd do another video, this time on solving quadratic equations. The first thing to note is that the difference between a quadratic expression and a quadratic equation. So this first one up that I've got up here, x squared plus 4x minus 45, this one here is an expression because it doesn't equal anything, and x squared plus 4x minus 45 equals 0 is an equation because it equals something. Now, to solve a quadratic equation, remember it must equal 0. There are three ways of solving a quadratic equation: by factorising, using the quadratic formula, which we'll be looking at today, and by completing the square. If an equation factorises, it is by far the easiest way of doing it. However, that will not always be possible. So I've got four examples just to work through. 6x squared plus 10x plus 3 is equal to 0. Now, a quadratic equation doesn't have a higher power of x than squared. X squared is the highest power in it. Now, before you solve a quadratic equation using the formula, I suggest that you first start by checking that it equals 0. This one does, so we're okay. The second things I suggest you check are that they are in descending powers of x. So what I mean by that is your x squared bit comes first, then your x, and then just the number. Now, to solve a quadratic equation using the formula, we've already made sure it's written in this form with the x squared bit first. You do need to know this formula over to the right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I've tried to colour code this just to help us out. So the first thing you're going to do is the number before the x squared, the coefficient of x squared, is going to be our value for a. So I always suggest just making a note of the different values. So a in this case is 6. B in this case is the number, the coefficient before the x, which in this example is 10. And then C is just the number on its own at the end. All we are then going to do is substitute these values into our quadratic formula. So x equals negative b. Well, if b is 10, negative b would be negative 10 plus or minus the square root of 10 squared, because that's our b. Take away, I always suggest that you put this next bit in brackets. The reason for that will become apparent later on. We're doing 4 times whatever a is, so that would be 6. And we're multiplying that by whatever our c is, which is 3. Now, that is all over, so the line has to go right to the start next to the negative 10, and that's all over 2 lots of whatever a is, which in this case is 6. So before I use the calculator, I'm just, let's move that down a bit, I'm just going to tidy up our formula a little bit. So it's negative 10 plus or minus, I'll come back to this bit in a second. 10 squared is going to be 100, and we're taking away from that whatever is in the bracket. I'm still going to leave this in brackets for the minute. Again, you might see why shortly. 4 times 6 times 3 is 72, and that's all over 12. So, tidying that up a little bit further, negative 10 plus or minus the square root of 100, take away 72, is going to be the square root of 28, and that's all over 12. Now, remember, a quadratic equation always has 2 solutions. It might be the same repeated solution, we call that one repeated root, and that's what this plus and minus bit is about. So we're actually going to do the calculation twice. X equals negative 10 plus the square root of 28 over 12, or x equals negative 10 minus the square root of 28 all over 12. So we're going to have 2 solutions. If I just bring up the calculator, and I suggest you use this button here to write a fraction. when we're using, rather than using take away, it's a negative number, so we're going to use that one. Negative 10, let's do the plus 1 first, the square root of 28, and then we can use our arrows to get to the bottom and write in 12. Press equals, and then use the S to D button. So x equals negative 0. Where's it gone? 392. Then to find the other one, you don't need to retype it in. You can just use your arrows to go back through and change that to a takeaway. And that one comes out as negative 1.27. So those two are our two solutions to our original quadratic equation, this one here. If I put in, instead of x, if I use negative 0.392 or negative 1.27 and put it into here, I should get 0. Okay, next example. It looks very similar, but watch out for the negatives. So you're going to start off exactly the same way. Does it equal 0? Yes, it equals 0. Do I have the x squares, then the x's, then the numbers? I do, so I'm all good to go. So I can write a equals, the coefficient of x squared is 4. B equals, the coefficient of x is negative 7. Please include the sign that goes before it as well. And then C is equal to negative 2. So now that I have those, I can just simply sub them into this formula. X equals negative B. Well, we're doing negative whatever B is. And because B is negative 7, negative B is actually going to come out as a positive 7. We are then adding or subtracting the square root of, I'm going to put negative 7 in brackets just to avoid anybody squaring 7 to get 49 and then putting a negative in front of it. We'll tidy it up a bit in a minute and you'll see what I mean. Then this bit in brackets as well, take away 4 times whatever A is, well A is 4, multiplied by whatever C is, which is negative 2. And that is all over 2 times whatever A is. In this case, that's 4. Okay, so if we just tidy that up and leave the space, x equals 7, positive 7, plus or minus the square root of, remember a negative squared, negative times a negative, negative 7 times negative 7 is going to give you positive 49. We are taking away whatever is in the bracket. 4 times 4 is 16. 16 times negative 2 gives you negative 32. And that is all over 8. So once again, just tidy this up before we put it in the calculator. Watch out for these. This is why I suggest the brackets, and this is a really common mistake that students make. You're not doing 49 take away 32. Because you're taking away a negative, you actually end up adding 32. So we're doing the square root of 81 and we're dividing that by 8. Okay, so now to get our two solutions, x is going to be 7 plus the square root of 81 all over 8, or x is going to be 7 minus the square root of 81 all over 8. So my two solutions to this one, we bring up the calculator again, clear that one. 7 add the square root of 81 all divided by 8. That equals 2. And then if I go back in and change that to a takeaway, that's going to be negative 0.25. Now this one actually would have factorized, but that won't always be the case. So those are your two solutions for that equation there. Again, if you put in either 2 or negative 0.25 instead of x into this, in the left-hand side of the equation, you would get 0 out. Okay, last couple of examples. This one here, remember I said right at the start of the video that to solve a quadratic equation, it must equal 0. If it doesn't equal 0, you can't solve the quadratic equation. So the first thing you're going to do is this is the type of question where you have to rearrange it to make it equal 0 first. So I suggest you choose the side with the fewest x squareds on it. So the left hand side of this equation has 4x squareds, the right hand side has 6x squareds. So I'm going to start by taking away 4x squared from both sides of the equation. So on the left hand side, I'm just going to be left with 12x plus 6. 6x squared take away 4x squared is going to give you 2x squared plus 23x minus 3. Okay, so it still doesn't equal 0. So I'm now going to get rid of that 12x. And whatever I do to one side, I have to do to the other. So I end up with 6 equals 2x squared plus 11x minus 3. Then I want to take away the 6, so that there's nothing left on that side. 0 equals 2x squared plus 11x minus 9. Now this is the same as 2x squared plus 11x minus 9 equals 0, because both sides of the equation are the same, so you can just flip them over. Okay. Once you've done that, you now have a quadratic equation that's in the form so many x squareds plus so many x's, and then a number, and it equals 0. So now it just becomes a question like the ones we were doing before. So a equals 2, b equals 11, and c equals negative 9. So using just do our formula over here, it was negative b plus or minus the square root of b squared minus 4ac over 2a. Now I'm just going to plug in the values like I did before. So x equals, let's do it in blue, negative 11, negative over b is, well, b is 11, that's going to be negative 11, plus or minus the square root of 11 squared, take away 4 times a is 2, and c is negative 9, and that is all over 2 times 2. So before we use our calculator, once again, tidy it up. The square root of 11 squared is 121. We are taking away whatever comes out when I multiply out, when I tidy up what's inside the bracket. So 4 times 2 is 8. 8 times negative 9 gives you negative 72. And that is all over 4. So one last line before we use our calculator. Plus or minus the square root of 121. Here it is again, we are taking away a negative. So 121 add 72 gives you 193. All divided by 4. So our two solutions are going to be negative 11 plus the square root of 193 over 4. Or we're going to have x equals negative 11 minus the square root of 193 all over 4. X equals, or x equals, bring up the calculator, put in the fraction, negative 11 plus the square root of 193 all divided by 4, press equals. So 0.723, or let's go back in and change that to a minus. take away negative 6.22. Negative 6.22. I'm giving all my answers to 3 significant figures. So those are your 2 solutions to this quadratic equation. If I were to choose one of those values, let's say 0.723, and substitute into this side, and then do this side separately with the same number, x equals 0.723, the 2 answers you get from both sides should equal each other. Okay, final example. Here is one of those questions that really kind of test understanding. This time you are given as if somebody has set up the quadratic formula to solve it, and you're asked to work backwards to find out what equation it was they were trying to solve. So we want to give our answer as an equation, but with values for A, B, and C. So the way we do that is we are going to compare this to the quadratic formula. Now there are some bits that are easier to do, and some bits are a little bit more tricky. The first thing, I'll do the A's in red. The A's are always the easiest bits to find because you know that this 4 has to be equal to 2A. So you could say 2A equals 4, and therefore if I divide both sides by 2, I get A equals 2. So that bit was nice and easy. That tells me that my equation is going to start 2x squared. The other thing that's relatively easy to spot, or relatively straightforward, is we know that negative 10 is the same as negative b. So I can write negative b equals negative 10. Now, although we don't write it, what that means is negative 1b equals negative 10. So if I divide this side by negative 1, and I divide this side by negative 1, I end up with b equals a negative 10 divided by 1. Well, 10 divided by 1 is 1, and negative divided by a negative is a positive. And then finally, this bit is a little bit more tricky. Everything inside that square root sign, we know that all of that is equal to 92. So I'll just do this underneath. I know that b squared minus 4ac has to equal 92. Now we've already figured out what a and b are, so we can actually use those to... So I've just realised that should be negative 10, my mistake. Negative 10 divided by 1 is... Negative 10 divided by negative 1 is 10. Okay, so now that I know what my values for a and b are, I can actually substitute those into my this b squared minus 4ac bit. So if b is 10, b squared, 10 squared, take away. I do also know what a is, and that's 2. And I know that when I do that, I get 92. So 10 squared gives you 100. Take away 4 times 2 is 8 times c gives you 8c is 92. Now, I don't like the fact that that's a negative 8c, so what I'm going to do is I'm going to add 8c to this side and add 8c to this side, because then that gets rid of this negative 8c. So I end up with 100 equals 92 plus 8c. This is the same as, the right hand side, the same as 8c plus 92, because when I add things it doesn't matter which way around I do it. What I've essentially done is I have put that over there. So now I'm going to take away this 92 from both sides, and I end up with 8 equals 8c. So if I then divide this side by 8 and this side by 8, that will tell me what 1 of c is, which in this case is 1. So I have now found my values of a, b and c. So when it asks us to find the equation that we were trying to solve in the form ax squared plus bx plus c, well, I worked out that my a was 2, so the equation is going to be 2x squared. 10 was b, so that tells me that has to be the number before the x. And then finally the number on its own at the end is a 1, that's a positive 1. So it has to be plus 1 equals 0. So this is the equation that led to putting those numbers into that formula there. Okay, so what I've done is I've made another question generator, and that question generator can generate lots of different questions here. So click new questions if you just want the type 1 sorts of questions. You can get the answers one at a time or all at the same time. And then you can get 2 or 3 or 4. You can also set increasing difficulty level. So question 1's the easiest, question 4's the hardest. Or you can, once you've got the hang of all 4 of them, you can practice just a mixture of them, where I don't tell you what kind of level of difficulty it is. That's it. Thanks very much for watching. I hope you found the video useful. Bye bye.